Okay, so on osmosis and diffusion, at this point, I'm wishing that Morgan Freeman can take over from me. Um, that was supposed to be a joke. I know it's probably not as funny, but anyways, so osmosis and diffusion. The diffusion of water through a semi-permeable membrane is called osmosis. Now, be very careful and make sure you pay attention to the fact that we said the diffusion of water. So, diffusion is a broader term than osmosis. Diffusion is actually the movement of any molecule from a high to a low potential, right? Or high to a low gradient. So, in this case, diffusion is a type of osmosis is a type of diffusion, but we're going to see more questions on this later on about the differences between both of them. Anyway, so the answer to this question is definitely B. Do not let any other option confuse you. Yes, there's movement happening, but it's not the answer, right? Active transport, we didn't cover it, but active transport is a type of movement of molecules from a place to another place, but it's not from high to low, and it needs energy. It's basically not covered in our curriculum for this year, and it's not the answer. Transportation, yes, transportation is happening when molecules are moving, but that's not the answer again. Okay, so question number 2. The figure below shows a beaker filled with water and a solute, right? The dots here represent the solute, and water is a bluish shade. The beaker has membrane down the center, which is permeable only to water. So this membrane only allows water to go through. What is going to happen, right? Option A. So water would flow into side A, right? That's the answer because we know that there is less there are less molecules of water here in A than there are in B, right? Or there is more solid concentration in A than there is in B, and so therefore water is going to move from where there's so much more water potential to where there is less water potential. So um, water is going to move from B to A basically. Okay, and that's the only option that makes sense in this, option A. Option B says water would flow inside B. That's wrong. Nothing. The water level is already equal. That's wrong. So it will flow from A to B. That's wrong. Even though we know we have more solid concentration in A, we know that the statement already mentioned that it's only permeable to water. The membrane is only permeable to water. So the solids cannot move from here to here. That's not going to happen. All right. So the answer to this question is A. I hope that makes sense. Now, next question is: an animal cell has 2% salt concentration. It's placed in a solution with 0.05% concentration. So this is the animal cell. It has 2% salt concentration, right? And this has 0.05%. Now, of course, we know that 2% is greater than 0.05, right? So it means that there's more water potential here in this than there is in this. Now, in that case, it means that water would have to move from here to inside the cell, right? That's we haven't even finished reading the whole question, but just reading the first statement, first two statements, that's what we can infer. Now, the question is asking, water would move, or stating that water would move into this animal cell, causing it to swell. That's true. From our logic, or from what we've just drawn in the diagram, that's going to happen for sure. And in fact, it's likely that this might cause the animal cell to burst. All right? I think that's question 3. Question number 4, the difference between osmosis and diffusion, or just definitions of them. In case you're asked this in the test, what is the definition of diffusion? It's a movement of any molecule or any particle from high concentration to low concentration, or from a high gradient to a low gradient, or from a high potential to low potential. Right? That's for any molecule, like we saw in the first question here. It's any molecule, any particle. Now, what about osmosis? Osmosis is a type of diffusion, but it is only focused on the movement of water molecules or water particles. Right? So do not confuse yourself, or do not get confused on this. It's the movement of only water molecules, and this happens through a semi-permeable membrane. In diffusion, it doesn't have to happen through a semi-permeable membrane. In osmosis, it must happen through a semi-permeable membrane. Um, so this also happens from a high water potential to a low water potential, and potential and concentration have a very similar meaning. When you're dealing with water, we look at potential, but if you write concentration on the exam, I'm going to give it to you as a correct answer as well. Okay, so that's it for those questions. I'm going to finalize on the last two questions, and then we can call it. We're done with osmosis. So in this question, um, the legend says that the smaller dots represent the molecules of water, so the, these dots represent water, and the bigger dots represent the dissolved substance. For example, um, starch. Now, what's the question saying? The diagram below shows a membrane through which osmosis can occur. This is the membrane, and we already know what these colors represent, what movement of molecules will occur. So we can see from here, because there's greater number of water molecules on the right side in B, we know that water is going to move from B to A. What else do we know? We know that if you look at this permeable membrane, okay, we can see that based on size, this object is quite big, right? It's quite larger than the water molecule, and this would not be able to pass through this membrane, right? So when we talk about semi-permeability, it's mainly because of size, right? So this object is not going to be able to pass through this membrane. So therefore, the solute, right, the dissolved substance, for example, starch, is not permeable or is not able to permeate through the membrane. So in this case, water is the only thing that's allowed to move through it. And therefore, because there's more water on the right side in B than in A, water is going to move from B to A. So this is not going to happen, right? And that's the answer to this question. So just always understand that size plays a huge role, a crucial role when we talk about diffusion or when we talk about osmosis, right? Um, Question 6. Diffusion and osmosis are very similar. What is a major difference between both of them? And give an example of each. So diffusion is not just the movement of it's not just the movement of water molecules, it's the movement of anything, of any molecule, right? Diffusion is the movement of molecules from a high to a low concentration until equilibrium is achieved. That's also true for osmosis, that equilibrium has to be achieved before it stops happening, or before the net becomes zero. But in diffusion, again, it's the movement of any molecule, of molecules in general, basically. In osmosis, it is focused on the movement of water molecules only, right? Only from a high to a low water potential. So that's it for diffusion and osmosis. If you have any questions about what has been mentioned in this video or any clarification that you need, please send an email and I should help clarify that.